So you got to figure out where to close the radicals, how to put a fraction into your calc. Offer. Just give me a couple. 1.573. That seems confirmed. So now what we want to prove is the other side is 1.573. So let's combine these fractions first. How do you add fractions? Common denominator. What's common between 3 and 4? Okay, so they're both going to go over 12. How do we change a 3 to a 12? Times 4, so the top times 4. How do we change a 4 to a 12? So top times 3. Add them together, we've got the sine of 7 pi on 12. Is that a unit circle angle? No, so let's throw this into our calc and get the approximation of it. Come on, 1.573. Offer? I love everyone's doing it again. Point, sorry, 8. No point. 831. 832. That doesn't sound confirmed. Somebody else? 0.965 sounds confirmed. So the point of all this is these are not equal. No, we cannot distribute a function. We cannot just take that sign and multiply by the a and multiply by the b. It doesn't work that way because sign isn't a number. It's just like a square root. We can't distribute among brackets. It doesn't work that way. Okay, what about this identity? Is it true? So let's do sine of 60 plus 9, or 30 plus 60, and then figure out this side. Okay, so let's do the left-hand side this time first. It's going to be easier. So let's add in the brackets. What is 30 plus 60? 90. And what is sine of 90? So top of the circle. Top of the circle. 1. Okay, the other side, so sine of 30. Remember 30 is pi on 6. So what is the sine of pi on 6? Off of root 3 over 2. Okay, cos of 60 is pi on 3. So cos of pi on 3, 1/2. Plus cos of 30, so cos of pi on 6. Okay, off of root 3 on 3. Root 3 on 2. But you said the sine of pi on 6 over here was root 3 on 2. I was waiting for someone to fix it. Okay, so we agree the sine of pi on 6 is 1/2. Okay, and all the way in, sine of 60, so that's sine of pi on 3. Sine of pi on 3. We just did it up here. Look up if you're not sure. Root 3 on 2. Okay, simplifying, I've got a multiplication, an addition, and a second multiplication. What do we need to do first? The multiplication. So I'm going to multiply these two, and then I'm going to multiply these two, and then we'll add them together. How do you multiply fractions? Okay, so 1 times 1, 2 times 2. The second set, root 3 times root 3. 3. And 2 times 2? How do we add fractions? Common denominator, which is already done. Add the tops together. 4 divided by 4? So is it true that sine of 30 plus 60 is the sine of 30 times the cos of 60 times plus the cos of 30 times the sine of 60? Yes. How come I'm allowed to? Because this is an identity because it doesn't have variables. So we're just proving those specific values. Okay. Questions so far, because this is going to help us get the formulas in a second. So point of this is no, you can't just distribute a function. If we turn the page, what we're going to look at now are 6 new formulas. They're called cos of alpha plus beta, cos of alpha minus beta, sine of alpha plus beta, sine of alpha minus beta, tan of alpha plus beta, and tan of alpha minus beta. What the heck are alpha and beta? Yeah, they're just Greek letters. They're just like theta. But what we're going to look now is when we're adding and subtracting angles, what's going to happen. So for example, on the last page where we did sine of 30 plus 60. Well, I can't call them both theta because there's 2 of them. So usually in English alphabet, we would call them x and y. Well, someone decided to use the Greek alphabet instead, so they're called alpha plus beta. These are just Greek letters. They're just variables. Now, an alpha looks like this when you're writing it. It's not a fish. It's not a Jesus fish. It doesn't look like an 8. It's not infinity. It's an alpha. That's what it looks like. Beta, when you write it, looks like a B, but it's got a longer tail. So it's not a regular English B. It's beta. Those are completely different symbols. All they just mean are variables. Okay? If you like to put x and y, then put x and y. Just note the formula sheet's going to have it like this. So let's go to our sine one first, because that's what we just proved in the last example, is we looked at sine of 30 plus 60. And so we just determined that the formula of alpha plus beta for sine is the sine of alpha, so whatever the first angle is, times the cos of beta, whatever the second angle is, plus the cos of alpha, the first angle, times the sine of beta. Okay, so just peek back at the last example. That's what we were doing here. Is we were doing that formula, we just didn't know it. So sine of alpha plus beta is sine of alpha times cos of beta plus cos of alpha times sine of beta. The point with this, it is not just sine of alpha plus sine of beta. You can't just distribute that sign and think that that's going to work for you. It's a function. If the question we had just done had a minus sign here, what would we have put here? A minus sign. So we call these the sum and difference identities because we can be adding or we can be subtracting. If the left-hand side is adding, the right-hand side is adding. If the left-hand side is subtracting, the right-hand side is subtracting. Well, there's an equal formula for cos, and here's what it looks like. It says cos of alpha plus beta is the cos of alpha times the cos of beta minus the sine of alpha times the sine of beta So let's just compare these and look at the difference. So what's the difference between the cos alpha plus beta and the sine alpha plus beta? We'll look at the 2 terms. So in the second one, or the first one we wrote down, we have sine cos, cos sine. What do we have up here? Cos cos and sine sine. So the coses are together, the sines are together. Here there's one of each. This started with a plus, it ended up being a minus. This started with a plus, it ended up with a plus. If I have a minus on this side, what do you think is going to happen over here? It's going to be a plus. And again, we use these whenever on the left-hand side we're given 2 angles that we're either adding or subtracting. Okay, tan formula is completely whack from those 2. It is tan of alpha plus tan of beta divided by 1 minus tan alpha times tan beta. So it's tan of alpha plus tan of beta divided by 1 minus tan alpha times tan beta. That's if you've got a plus on the left-hand side. What about if this happened to have been a negative? This one becomes negative, and this one becomes positive. There are your 6 new formulas. They are cos of alpha plus beta, cos of alpha minus beta, sine of alpha plus beta, sine of alpha minus beta, tan of alpha plus beta, tan of alpha minus beta. Are they on your formula sheet? Okie doke. Are all of them on your formula sheet? Not the other sign. Okay, so you just need to know that you're going to switch the signs. The point of this is not equal to cos alpha plus beta, cos alpha plus cos beta. And this is not equal to tan alpha plus tan beta. Okay, you can't just distribute the function and think it's going to be the same. So on your new pink card, these are going to go on the front. The back is going to be saved for the formulas we're going to look at tomorrow. Okay, so your new pink card, you can put these on the front if you wish.